transverse waves like this. So, and these superposition of the waves includes the stationary waves, beats, and as well as interference of the waves. And in the stationary waves, we'll be seeing the stationary waves formed in the strings and in then pipes and resonance column apparatus. Along with that one beats. So another one is the last section of this one is going to be a Doppler effect. Okay. So these are the certain things that we'll be discussing in this chapter consists of. So we can expect one question from this particular topic. Okay. So let's start with this one. Let's deal some of the important topics that are being identified by our research team. So first one is called as the principle of superposition of the waves. Another one is a transverse wave in a string, argon pipes, beats, and the Doppler effect. So these are the things that we are going to discuss today. So coming to the first one, principle of the superposition of the waves. What do you mean by superposition of the waves? So in this superposition, two waves or two progressive waves, let us assume the first wave is going to be the y1 is equal to whose amplitude is a sine of some omega t minus kx, and another wave which is in y2 is equal to this is a sine of omega t plus kx. So I have taken this plus kx in the sense the wave is traveling along the negative x-axis, minus kx means the wave is traveling along the positive x-axis. It doesn't mean that superposition has to be takes place between the two waves which are in the opposite direction. So according to the principle of superposition, that means y is equal to it will be always y1 plus y2. That is the resultant displacement of the two waves is equal to the sum of the displacements of the individual waves. So there are the three types of the superpositions that we'll be discussing here. First one is called as the stationary waves. Stationary waves. And the second one is called as your interference. Interference of the waves. And the third one is called as an beats. So in the stationary waves, the two waves will be in opposite directions. Whatever the two waves are there, two waves will travel in opposite direction. So they are going to be opposite direction waves, two waves with a slight difference in the phase. And whereas in the interference, the two waves or two or more waves will be will be traveling in or same direction. So with a slight difference in phase. With a slight difference in phase. Whereas beats also two waves traveling in same direction with slight difference in frequency. So this is the main difference between the three types of the superpositions. So in this one, let me go for the first case, which is called as the stationary waves. So most of the questions will be asked on this particular concept. That is your first condition, which is stationary waves. stationary waves. So in this one, what will happen? The two waves are going to be traveling in a same direction, opposite direction with its amplitude will be same, or they can be different also, but they will be superimposing on each other like this. So one wave is going to be overlapping on another wave, or it can be the incident wave and it will be the reflected wave conditions like this. Okay, so these locations where they are going to be having the uh, where the amplitude is going to be zero, and those locations are called as your anti nodes, and the where the amplitude is maximum, these locations are called as an antinodes. So these are antinodes, and these locations are called as nodes. So the particles in a specific, that means the particles in one loop will be, all of them will be in the same phase. That means all the particles will cross the mean position at the same instant of the time, at the same time. That means they are in the same phase, and the adjacent loop will be in the opposite phase to the other one. So adjacent loops are in the opposite, but the particles which are in a loop, they will be in the same phase. So suppose for this particular equation, if you can write that, then y is equal to, this is y1 plus y2. Then the equation of your stationary wave will be come out as an, it is 2 a into sine of omega t into cos kx, or this equation can be rearranged as an 2a cos kx into omega, sorry, sine of omega t. So this is an equation of a stationary wave. So how does the stationary wave equation in a given situation? Suppose if we identify a single loop and your equation is y is equal to, this is 2a, this is cos kx sine of omega t. 2a cos kx is going to be representing the amplitude of the stationary wave or the particle at a given position x. Suppose if you take consider this to be an origin, then at a distance called as an x, you can find out what is an amplitude of this one. This represents your a dash value at a given particular distance, please. So this is your a dash in this case. So this particular first part of the equation will be representing the 2a cos kx. That means particles are starting from the extreme position and they are moving towards the mean position like this. Okay, there are different equations depend upon the situation. You have to identify the stationary equation. This is one such equation where the particles are going to origin x is equal to, at x is equal to 0, it is having the maximum thing. That means the wave is starting with an antinode like this. That means your origin will be at this particular instant. Your origin will be at this particular instant correspondingly. So suppose if the equation is going to be the y is equal to 2a sine kx and sine of omega t. That means the origin is a, that is x is equal to 0 is a node, whereas in this case at x is equal to 0 is antinode, and in this case 2a sin kx particles are moving from the mean position towards the extreme position, whereas cos kx particles will be moving from the extreme position towards the mean position. You can also have another sort of an equation where y is equal to 2a cos kx cos omega t. So this represents that particles are moving from an extreme position towards the mean position. Another equation, y is equal to 2a sine kx cos of omega t. In this case, particles are starting from the mean position towards the extreme position, and at x is equal to 0. Since sine, for the sine functions, you can have the x is at x is equal to 0, node will be there. For the cos kx terms, At x is equal to 0, it is starting from the anti-node. So the distance between the node and a node is lambda by 2, and the distance between the node and antinode is lambda by 4. So by using this equation, these things, so we this lot of stationary wave conditions, stationary wave applications will be given to you. So based upon the information given, identify the particle's location, at which location the particle is at there from the origin. So correspondingly, you can also find the amplitude of its. So the remaining term is going to represent that alternatively maximum and minimum of the amplitudes. Okay, so this is basically the stationary wave conditions. So this is these out of these four equations. One, this is two, this is three, and this is fourth equation. They can ask you or they can give you any type of the equation. Based upon the equation, we have to judge whether the particle is starting from the mean position or extreme position, or at x is equal to 0, whether it is starting from node or anti-node. So based upon that one, you can identify whatever the terms are there. Now coming to the transverse waves of the string. So transverse waves are nothing but these waves are going to be propagating perpendicular to the propagation of the wave. For example, y is equal to, if I write a sine of omega t plus or minus kx. So this is x along, that is wave is propagating along the x direction, but the particle is vibrating in the y direction. So this is basically the stationary wave, sorry, transverse wave, where the wave is being propagating along the x-axis, whereas particle is moving or vibrating in the along the y-axis like this. So this one equation explains the horoscope of the particular particle. In the sense, suppose if you consider a particle P over here, so what is the maximum value of the displacement the particle can make? That will be provided by the A in the equation, where A is called as an amplitude, and sine function is going to specify that it is alternatively changing from the positive cycle to the negative cycle. Omega is called as an angular frequency. Omega is called as an angular frequency, and K is called as an propagation constant. Propagation constant, and X gives you the location of particle from origin. Okay, so it will give you the location of the particle from the origin, please. So that means it's going to be specify everything regarding a particle which is in an wave. So this is the main thing. So based upon this one, transfers have framed the laws according to the velocity of the wave. It can be written as an frequency into lambda. Wave velocity is equal to wave velocity frequency into lambda is equal to, but transverse wave it is t by mu. From this one, we can say that fundamental frequency f is equal to 1 by lambda into root over t by mu, where lambda is equal to the, where there is a wavelength is equal to 2 times of the L. If I take the total length of the wire as an L, and a node and another node is forming over here, this length is going to be the L. Then this is the situation after substituting f 1 by, this is 2L into root over t by mu. So now from this one, the three laws of transverse have been framed. That is, frequency is inversely proportional to the length. First one, frequency is directly proportional to square root of tension. Frequency is inversely proportional to the square root of linear density. Okay, so these are the laws of transverse wave. A transverse wave is going to be traveling in a string conditions. So we will be finding the frequencies and the remaining terms in the string instrument when we deal with an transverse wave conditions. So these waves are going to be traveling. One transverse wave is going to be moving in a forward direction continuously. So it's going to be moving. So in this case, the frequencies of all of them is going to be these laws inversely proportional to the length. A lot of questions can be asked on this particular thing. That is, the frequency is directly proportional to the tension. Frequency is inversely proportional to the length, and directly and inversely proportional to the square root of the linear density. So here, linear density mu is called as your mu means linear density. That is nothing but the mu is equal to mass by length. Okay, so these are the laws of transverse. So in a string, suppose if the stationary wave there are there, suppose if you fix the 2 points A and B, then if one transverse wave is moving from an A to B and it is been reflected back from the B to A, it forms a stationary wave. Suppose the length of the string is going to be the L and only one loop is formed. These are the nodes and this one is an anti-node conditions. Then you can say that lambda by 2 is equal to L, that is the length of this one, lambda is equal to 2L. From this one, fundamental frequency can be written as an 1 by root L in 2L into root over T by mu. Suppose if I make the same string to vibrate in two segments, if I make the same string to vibrate in the two segments, that is the total length is being divided into the lambda by 2 and lambda by 2. The total distance is being divided into the total length is divided into the 2 lambda by 2 here. So that means L is equal to lambda by 2 plus lambda by 2 or lambda is equal to 2L by 2 if I substitute in the fundamental frequency condition or frequency formula. This is equal to the 2 by 2L into root over T by mu, and this is frequency. This is called as in 2 times of the fundamental frequency. So these are called as an harmonics. The generally for the string instruments, the frequencies will be in the ratio of 1 is to 2 is to 3 is to 4 is to like that. The frequency are these are called as an harmonics, and the higher levels of the frequencies are called as an overtones. That means your second harmonic is called as an first overtone, and similarly, the third harmonic is called as an second overtone. Like that, the nth harmonic is called as an or else n plus one harmonic is equal to nth over tone. Okay, so this is how it's going to be divided. So he can ask you that for one particular string, suppose the third harmonic of the first string is being matched with the fourth overtone of the second string. Like that, they will be framing the questions and they might be asking you the length relations, conditions, or tension, whatever maybe the different parameters are there, they can be asked. So now the same these organ pipes are also work on the same type of the waves, that is stationary waves. So in this case we will have the two types of the organ pipes. One is called as an closed and the second one is called as an open organ pipe. So where I go for first case, the second case that is open argon pipe. So what is this open argon pipe? If a pipe is having the length L and open at both ends is called as an open argon pipe. So in this one, if we try to produce a wave like this, that means two antinodes are being formed inside the wave and one node is being formed for a length called as an L. So obviously we know that distance between the antinode and the node is lambda by 4 and this distance is also lambda by 4. So from this one, from frequency relationship, V is equal to frequency into lambda. From this one, lambda is equal to, or L is equal to, I can write it as an lambda by 4 plus lambda by 4, that is equal to the lambda by 2, and the lambda is equal to 2L. So on substituting, F is equal to, it is V by 2L. So here theoretically we are taking that or considering that antinode is exactly formed at the end of the pipe. But practically it may possible or it may not possible cases. Practically it may possible or it may not possible situations will be there. So that is because of the pressure that is we build up outside the open end due to the atmosphere. Okay. So by practically or theoretically, you do consider this distance as a lambda by 4. But what happens if the antinode is exactly formed at some distance outside this one that we cannot measure it, and that is called as an E, where E is called as an end correction. Where E is called as an end correction, which is equal to the zero point 0.6 times of the R, where R means radius of the pipe. Radius of pipe. Okay, so this is the then formula of the frequency can be converted into the V by 2 times of L plus E. So this is how it's going to be turned out. Now, well, if I go for an closed case, or else if I go for the another loop, in this one, the same open side, for the same length of the pipe I'm taking here. So if we try to form the two loops over here, then like this. This is your antinode, node, antinode, node, and antinode. So the total length is dividing into the L is equal to first term lambda by 4, again lambda by 4, lambda by 4. So 1 lambda by 4, 2, 3, 4. So that these are your distances, please. So now from first antinode to the node, it will be lambda by 4 as I have written, and node to the node, the distance is lambda by 2, and the last is also lambda by 4, which is equal to the 2 lambda by 4. And when I substitute this for the frequency, we'll be getting it as an V by, so 2 lambda by 2, sorry. So now we'll be this will be the 2V by 2L, or 2 times of the fundamental frequency, that is F naught conditions, please. Okay, or in the case of the end correction, the same thing can be written as a 2V by 2 into L plus E. Okay, so this is our situation. Now if we go for an open organ pipe, so or else this case in the closed organ pipe, in the open organ pipe condition, what will happen? The frequencies are in the ratio of the 1 is to 2 is to 3 is to, like that. Okay, the frequencies are in the ratio 1 is to 2 is to 3, like that. Okay, so now coming to the closed one. So closed organ pipe means one of its end will be closed and other end is going to be open. For example, like this end is closed and this end is open. So if a source is there here, okay, so what will happen? The wave that's gone, or else you can generate the waves by using a tuning fork also. And these waves, what they do, they move into the pipe and they reflect from the surface and they come back like this. So that means a wave is being generated in this way. It's going to be hit this closed end and it's going to be coming back in this way. Okay, so this is called as, and suppose the pipe is only up to this particular thing, and this is called as your end correction. This is lambda by 4, and the same length is L. Okay, so in this case, L is equal to lambda by 4, or lambda is equal to 4L. Next, K, we have got the lambda here. So when we substitute the frequency, F is equal to V by 4L. V by 4L in the sense, This is the basic thing, and if you consider the end correction also, the same formula can be written as an V by L minus phi. Sorry, V by L minus E or minus 2E, because open by, oh, yeah, so it's going to be the 4L plus E or 4L minus E, depend upon the situation over there. So, but we go for 4L, right? So, this is our end correction conditions also, and the frequencies are in the ratio of 1 is to 3 is to 5 is to, that is odd numbers will be there. Okay, now are in a specific in the order. Okay, sir. So this is the speciality of the closed vibes, and next one is called as in beats. Beats is, as we have discussed, the two waves traveling in same direction, same that they are going to be traveling in the same direction and superimpose. So this is the main thing. Fine, sir. So the same equations you can write, that is y is equal to a into sine of omega 1 t plus a is equal to sine of omega 2 t. So slight differences in the frequencies, that is a sine of 2 pi f1 into t plus a sine of a sine of 2 pi f2 into t. So this is how we can expand them, please, basically. Okay. So when these two waves are going to be superimposing, then you will be getting the number of beats, or the beat frequency can be written by beat frequency, that is delta f is equal to f1 difference f2. F1 may carry the higher value and f2 may carry the lower value. That's the only difference, please. And the f2 minus f1 will give you the number of beats per second, difference in the number of beats per second. Okay, fine. Coming to our this topic, Doppler effect conditions. A Doppler effect is the one in which there will be a change in the sound heard by the observer when the source is making the sound, or when the source is moving, or only observer is also moving. Suppose if we try to walk on the surface or on the road and you are approaching towards a source of the sound. So when you are approaching the source of the sound, what will be happening? Your frequency will tend to be increased, or that means you will receive the more number of the waves, that is sound heard by you is going to be the much larger. Or else if you are stationary and sound producing instrument is coming closer to you, then also in that case also you can find out the change, apparent change in the frequency heard by the observer. That means when we can find out the change in the frequency heard by the observer, either the source should move or observer should move, or both of them will be moving. In whatever be the case like this, you can find the change in the frequency heard by the observer. So that phenomenon we call it as an Doppler effect, and that phenomenon is the main thing is important Doppler effect. For example, if a source is at rest, the apparent frequency the apparent frequency heard by the observer heard by the observer when a source is moving or an observer is moving, an observer is moving, or both of them. Both of them. Okay, anything change it can give you. Example source is the one which is producing the sound waves. Suppose the person is here. This is your observer. Okay, so this source of a sound can be reached to some other point, please. So here, if you are moving, then your frequency might be changing. Or if you are stationary, also stationary, so stationary observer, this is also happens. Okay, so when source is moving like this, and so velocity of the sound will be always in the direction of the force to the observer. And if source is at the rest condition, then if you can write the formula as F minus what is the basic condition? That is the frequency or the velocity. V minus V naught is not possible. That then V minus Vs. V minus Vs velocity of the source and velocity of the observer are in the same direction. You can get it. Okay, so this is how we can write out the equations of the frequencies, how they can be in this case. That is how the frequencies are changing in whenever the source is moving towards the observer or source is moving away from the observer. So these type of the things it will be useful for us. And the Doppler effect can be changed. Suppose, for example, it can be framed by a single formula. F dash is equal to m plus or minus that is v plus or minus velocity of the wind minus or plus velocity of the by velocity into plus or minus velocity of the wing plus minus velocity. So this is how it's going to be happening, sir. Okay, so into F naught, this is the one which is called as an change the frequency with respect to each and every one. So now, if any object or a rail is been traveling in this way, how do you find out the apply the Doppler effect? An observer is here, it is found to be stationary in the rest position, and source is at this particular point, velocity of the sound is here. Source is at F. Source is yes, moving towards moving towards the the point A. So in this cases, what sort of a Doppler effect do you have to observe? This is the velocity of the source Vs, this is the velocity of the sound, yes, making an angle theta. Then how do you write the frequency for these type of the things? F dash is equal to V plus V naught by V plus this is going to be how much, sir? That is so Vs cos theta. Fine. So in this case, these are the different things that an different situations. For example, if at all it is moving in a circular path, then you can replace with the V naught as an R omega. If it is moving in a circle in a known format, repeat the same change or convert the acceleration into that chapters or that concepts model. Then it will be comfortable for you to solving the sums, please. So this is one of the major important concepts. So now I'll close this session at this particular instant. Thank you everyone for listening to go through